Our first idea was to have one big tank on top because you need a tank to put the air for the piston in. But we changed that and went to 2 tanks, and we mounted them like this. There's a nub on each end, and we have a hole. The bracket fits right around it like that on each side. Both tanks, same thing down here. And the tanks are mounted in there so they can spin, but the rules say they have to be structurally mounted. They have to be part of the structure, so that's the way they are. Then next we needed a piston. So this piston has 153 pounds of force at 65 psi. It only has about 0.8 inch stroke, so we'll call it a 1 inch stroke, but we're using a lever basically to make it so that our flipper will move 4 inches.
What's a stroke?
Stroke is how far it comes out.
Ah, okay.
The distance that it comes out. So and then you need a regulator. This is a regulator. The tanks, you pump those up with a bicycle pump up to 150 psi. So these you pump up. Then these tubes, there's some that come out of the tank. They come around, they come through here. These are going to be for our pressure relief valve and a tank filler valve. They come around through here, they go into the regulator. The regulator takes the PSI that's coming in, 150 PSI, and puts it out the other side at 65 PSI or whatever we set it to using this little knob right here. So that it'll come out at 65 PSI. Under here, you can actually see from the bottom, is a valve. The way it works, the air comes into the valve, and then the valve fires that air right into the piston. Very, very quickly, because that's the whole idea. So you get a quick burst, and it shoots this out. And this comes out at 40 inches per second, which means that it extends in about, we're saying we're going to cut that in half because it's 20 to 40 inches per second. So this will extend in 0.05 seconds, which means that we have a lever that's going to flip up. It's going to move the same distance. It's going to move 4 times the distance with a quarter the force. So technically we'll be about, I don't know, a quarter of 150. So say about 40 pounds of force. 40 pounds of force, but it's going to move 4 inches in 0.05 seconds. And our flipper, our idea, we did have an idea, it was going to be just a basic spatula, like a scoop like that, but we changed it around and we turned it into 2 forks, so it'll be like a forklift. Because when you think about it, the way a scoop works is it gets under something, and if this is the bot, it gets under it like that, and you flip it. Now, most bots aren't real thin or aren't real narrow, so if you have 2 things like this, the chances that a bot is going to get in between are very, very slim, and we need the weight. So the forklift idea is simpler, still gives us essentially the same usable area, I guess you could call it. So this way we'll be able to drive a little faster. We'll have the extra weight. We won't, because it's a 15-pound class, so your robot can't weigh more than 15 pounds. And hopefully the plan is we have a lot of speed with these motors, so we'll be able to maneuver quick, get underneath them, fire the piston, and it flips them over. So we did all the physics, we did all the math, and that should be able to flip a robot over.